Hello student, in the last two lectures we have started with the unit 2 discussion, that is intersection of solid. We have studied the content, that is types, vertical solid, horizontal solid, the axis relations with the principal planes. As we already know the principal planes, horizontal plane on which we draw the top view, vertical plane on which we draw the front view of the object, and the side view plane. Here are two solids, vertical solid and horizontal solid. The axis of vertical solid is perpendicular to HP. So first we have started the top view, then front view, and then side view of the vertical solid. Now here the horizontal solid whose axis is parallel to both HP and VP. Its cross section is seen in the side view plane. So we have started the first projection, that is the first step, side view of the horizontal solid, then front view of the horizontal solid, then we have drawn the top view of the horizontal solid. Here we have to study the three cases with respect to the axis of both the solids, that is vertical solid and horizontal solid. The relationship between the axis, there are the three cases I have shown here in the figure. That is the first case here. Both the axes. This is the axis OP. This is the axis OP of the vertical solid. Single point is observed in the HP, horizontal plane. This is also the axis OP of the vertical solid. This is the axis of vertical solid. This single point UV is the axis of the horizontal solid. This is the axis UV of the horizontal solid. This is the axis UV of the horizontal solid. Here I am showing the figure. This is the vertical solid. This is the vertical solid. It is a square prism. We are discussing both the solids of square prism whose rectangular faces are equally inclined to VP. These are the rectangular faces. These are the rectangular faces which are equally inclined to the vertical plane VP. Now this axis, this is the vertical axis and this is the horizontal axis. When both axes bisect each other, this is OP, vertical solid axis. This is OP with single point here. This is the UV. This is the UV. This is of a single point here, and it lies on this vertical solid axis. That is called bisecting. Bisecting. Now here in the second figure, same object, same solid, vertical solid, horizontal solid, square prism. Now this axis is shifted. This is the OP. This axis is UV. It is shifted. This axis is shifted in front of this axis. This is the front side by some eccentric. This is the eccentricity. But this corner of the horizontal solid is not crossing the vertical solid. It is not crossing the vertical solid. But in third figure, it is the axis UV is eccentric. This is the axis OP of the vertical solid. This is the axis of the horizontal solid. But this horizontal solid crosses the boundary of the vertical solid. These are the three cases which we are going to study here. Now, I will name the points. For the vertical solid, here I have named it AA, BB, CC, DD. AA, front side, BB, back side, CC, and back side, DD. This is also axis. Similarly, this is AA, BB, CC, DD, as well as OP of the vertical solid. In the side view, this is the DD. This is the point DD which I have transferred here. These are the 2 points, that is C, this is C and this is A and C, and this is BB. In all the solids, I will name it as AA, BB, CC, DD, AA, BB, CC and backside DD, DD, AC and BB. Here I will name as A, BB, CC, DD. Okay, and this is the OP. O dash P dash, this is the axis. They will give the height. This is the D double dash. Here I have transferred here D double dash, D double dash. This is the point C double dash, C double dash. Also A double dash, A double dash. Also B double dash, B double dash. This is the point A dash, A dash. This is the point B dash, B dash, front side, middle side OP and back side D dash, D dash, C dash and C dash. These are the naming of for the vertical cylinder. Now I will name for the horizontal cylinder. This is the point. This is the point 1 1, 1 1, 2 2, 3 3 and this is the point 1 1, 2 2, 3 3 and 4 4. Here after rotating I will draw on this side and rotated here. So 1 1 comes in this side. 1 1, 2 2, 3 3, 4 4. This is the 4 4 front view. This is the 1 1. 2 2 and back side 3 3. For top view this is 1 1, this is 4 4, bottom side is 2 2 and 3 3. Similar here, this is the 1 1, 1 1. This is the 4 4, 4 4. This is the 2 2, 2 2 and back side 3 3. For top view this is the 3 3, 4 4. This is the 4 4. This is 3 3. This I have transferred here. This I have shown the arrow 2 2 and 1 1. Similarly, I will name for this is the point UV. This is the point UV. Here I have shown the same name, but here is the eccentric, and this horizontal solid is not crossing the vertical solid. I have named it as 1 1 2 2 3 3 4 4. I have transferred it 4 4, 1 and 1, 3 and 3. 2 and 2. Similarly, I have transferred this 3 3 here 1 1 2 2 and 4 4. 2 2 and 4 4 and this is 1 1. Similarly, here we also name this is 1 1, 2 2, 3 3, 4 4. This will be your 4 4, 1 1. This UV, this is the axis OP and this is the axis of horizontal. This is the eccentricity. Both the axis is having eccentricity. And this corner is crossing the border. This edge is crossing the boundary. So I will name it as 4 4, 1 1 as well as this line here 3 3, 3 3, 2 2. Here this is the point 3 3. 2 2. 4 4 and 1 1. Now we have to draw the line of intersection. For this side I will consider P side, entry side. This side Q side I will name this 3 3 line. On this 3 3 line I will name it as P3. This is exit side Q3. This is the point which touch the vertical solid surface. Here 3 touch at this point, leaves at this point. Where is touch at entry? I have named as P. This is the vertical solid. This is the horizontal solid. Here it cuts. I will name it as P2 and P4. Same name, just added P, Q2 and Q4. Here P1 and Q1. Similarly for the second figure, 3-3 line, I will name it as P3, Q3. This is the point P2 and P4. This is the point P2, Q2, Q4. This is the point P1. This is the point Q1. Similarly here, this is the point P3. This is the point Q3. This is the point P2 and P4. This is the point Q2 and Q4. This 1-1 line does not cut to the vertical solid, so it is not necessary to give any name to that line. Now here is the addition. In this figure, second figure, eccentricity. This is A and CC line. This is A and C. Okay. Now, as this eccentricity is available here, so this face of the horizontal square prism also cut to AA and CC. So I will name it as M double dash N double dash. In the third figure, there is eccentricity for this face. I will name it here M double dash N double dash. That lies where the M and N lies on AA and CC, as well as the horizontal square prism, horizontal solid crosses the boundary. So it cut to the BB. Here I will add U double dash and V double dash. UV lies on BB, MN lies on two generator AA and CC. Now I will transfer this point as P3. Where is P3 and Q3 lies? On which edge? Horizontal edge 3-3. So in the front view, I will transfer. Here is a 3-3. This is a 3-3. I will transfer this point. I will name it as P3. Here I will transfer on which edge? It lies on 3-3 in the top view. I will transfer it in the front view. I will name it as P3. This is the point Q2 and Q4. Here is Q2. Here is 4-4. So I will name it as Q4. Here is 2. I will transfer it P2. And this is P4. Now P1 and P3 are exactly backside to each other because it exactly both the axes, solid axis, bisect each other. So P1 also lies here. This is Q3. This is Q1 also lies here. Similarly, here I will transfer. This is the point P3. I will name it as P3. This is the P2 and P4. Here P4 and P2. Here is, I transfer it where is 1. This is P1. This is Q3. Q3 on 3, 3. This is Q2 and Q4. I will transfer it here. This is the Q3. This is the point 2, 2 and 4, 4 lines. So we have named as Q2 and Q4. 2, 2 line. This is the point Q2. This is the point Q4. Here is a 1, 1 line. So we have named as Q1. This is the point Q1. Similarly, we will transfer this point here. This is the point P3. This is the point P2, P4. This is the point Q3. This is the point Q2, Q4. This 1, 1 edge does not crosses to any part of the vertical solid, so it will not contribute in the line of intersection. So it is not necessary Q1 or P1. Now in the second figure, eccentric without crossing the boundary, eccentric 2 points are added here. M and N. M and N lies on AA and CC. Here is AA in front view. This is the CC. So I will transfer this point where this point lies on AA and CC. This is AA. So I will name it as M. This is the point M. Here N. N also lies on AA and CC. AA and CC. This is the point N, and this is the point I have transferred. This is the point N. Similarly, eccentric crossing the boundary. This is M lies on AA and CC. This is AA and this is CC. This will be our point M. M. This is the point N. N. Again, U and V lies on BB. Where is BB in the front view? This is the BB. B and B. So I transfer this UV in the front view that lies on BB. Here I will name as U. Here I will name as V. Now we have to join the line of intersection. This sequence 1, 2, 3, 4. Where is point 1? 1, 2, 3 is backside 3 and 4. 1, 2, again 3, backside, that is dotted, again 4, backside. Here we will draw the line sequence after 1, 2. This is the point 1, after 1, 2, after 2 and this is the backside portion. This portion is backside portion. So I will draw the dotted. After 2 it is N. This is the dotted N. After N3, that is also dotted backside. After 3M, backside. after M4, that is also dotted, and after 4, 1. 4 and 1. This will be dark. This is the front. This is the front face. This is the front face. Here we will observe here. This is the front face. This is the back side which we don't observe. This side. This side is the back side portion. We don't observe. This side is the back side portion. We do not observe this back side behind this vertical. We do not observe. That will be the dotted. The same sequence on this side. 1, 2 and 3 and 4. 1. This is 1. After 1, 2. After 2, now this will be the back side. N. Here is N. This will be the dotted. After N, 3. This will be the dotted. After 3, M. After M, 4. After 4, 1. After 4, 1. This is that. Similarly here, sequence. Now here we will start without starting from 1. We will start from U. After U, after V. We will take first V. Or we will take a U. We will take V. V. After V, which part is there? This is the front side. V. This will be dark. V to 2. 2 to N. This will be the dotted. 2 to N. N to 3. Dotted. N to 3. 3 to M. 3 to M. Dotted. M to 4. 4 to U. 4 to U. This will be dark. Similarly on Q side. V2. V to 2. Dark. 2 to N. Dotted. N to 3. Dotted. 3 to M. M to 4. Dotted. And 4 to U. This will be the dark. Now this is the difference between the three types. First, bisecting. Second, eccentricity, offset without crossing the boundary. We observe two curves. This is the front side curve. This is the back side curve. Behind means the dark which we have shown. This is the front side curve. These two edges, and this is the back side curve, which is behind this. This is back faces, which is behind these faces. Okay. Now here, offset, crossing the boundary, both the curve will join here. Both the curves are separate. Here, both the curve overlap each other. This is the front side, exactly back side dotted curve is there. Now, we will have a discussion. Now, here, the vertical solid is cut, or the material of the vertical solid is removed, until and unless we remove the solid of vertical member, the horizontal member will not penetrate. So, there will be the edges of the horizontal cylinder which is inside the solid of the vertical will be shown by the dotted line. This will be the dotted line. Here this will be the dotted line because it is inside the solid. This will be dotted line. Here this will be the dotted lines. This will be the dotted line. This will be the dotted line. Now if you observe carefully, Q1 and P1 is dotted. Here Q1 and P1 is dotted, and apart from this line is dark. Here Q4 to P4 is dotted. This is the dotted and this will be the dark line, which is here Q2 and P2 is dotted. inside the vertical cylinder, and this will be 2 to Q2 will be dark, 2 to P2 will be dark. Similarly, same case, this dotted line here, this is the dotted line, this is the dotted line, this is the dotted line because it is inside the vertical cylinder, Q3. Where is the Q3? This will be the dotted line and this will be the dark line. Here Q2 and Q4, P2, Q2, P2 and Q4, P4. This will be the dotted line. And this will be the dark line from P2 to 2 and Q4 to 4, P4 to 4. Similarly here, Q3 to P3 the dotted. Where is Q3? This will be the dotted. And P3 to 3 the dark. This will be dark. Q2 to P2, Q4 to P4. This will be the dotted. Q4 to P4, Q2 to P2 will be dotted, and P2 to 2, Q2 to 2 will be dark, Q4 to 4 will be dark, this will be dark line. Which part is cut here? From M to N. This part is, this portion is cut, this portion is cut. This will be dark. Now, this is your D to D. This is complete dark here. This will be the complete dark here. Okay. From A to A, M and N is cut. From A to M, this will be dark. N to A, this will be dark. Similarly, for C to M, this will be dark. C to N will be dark. This part is cut portion. We have to draw it very frank. Similarly here, D to D, this will be dark line because it is not hammered by any horizontal edges, as well as this is B to B, this will be the dark line, complete dark line. Now where is cut this portion? M to N is cut of which solid? Vertical solid. So A to M, this will be dark, and N to A, this will be dark. Similarly, C to M, it will be dark. Here this material is cut. In this figure same, this will be dark line. This will be complete dark because it is not hammered DD and BB. Up till this it is hammered, this portion is cut. So this much portion is cut here. In this way we have to complete the 3 types of figures. In the next lecture we will have discussion about cylinder to cylinder. Okay, thank you.